Yeah, hello everybody. I'm Simon Lee. Thank you for attending the webinar. Uh, I'm the main developer of the GSK, and a new version of GSK, version 1.2, was released this week. So in today's webinar, I'll introduce some new features of the new version. And before starting the seminar, I let you know how to ask your questions during the webinar. So in your screen, at the right bottom corner, you will see 3 icons. And by selecting this Q&A, you can leave you ask your questions, and our panel, Kate, will answer the question during my presentation. And if some of questions are not answered, I'll answer your question at the end of my presentation. So please don't hesitate to ask your question even during my presentation. So today's webinar consists of 5 parts. Firstly, I'll briefly overview the GSK. I think some of this contents was covered by the previous webinar by YJ a few months ago. So I'm an engineer. I'm the main developer. So I'll focus on some technical details about GSK, especially compared to the device SK, our current SK. And after that, I will introduce some new features of new versions. And after that, I provide some rough direction of our new GSK versions. Even after releasing version 1.0 this week, we already started the development of a new version. So I will share some planned new features of new SK. And lastly, we will have very short Q&A session. GSK was, the development of GSK was started last year. So when first designing the SDK, we have 4 main goals. The first of them was that the new SDK should be more scalable and more extensible. The device SDK, our current version of SDK, is very mature and stable platform, but it has some issues. It has some issues, especially handling hundreds of devices. So the first design goal of GSK is its scalability and extensibility. I describe in more detail in my later slides. And another issue of the device SDK is that it can only support 2 languages, C++ or in some complex way, C#. But if we want to use another language, there was no option. So the second design goal was to provide language neutral the idea, and by using this, we are trying to provide many popular programming languages. And lastly, you can use the device SDK when you are developing some mobile or cloud-based application, but you have to many additional works to adapt the device SDK in cloud environment. So the last design goal was to make developing cloud-based application as is possible. So with design goals, we also targeted 2 types of new customers. Firstly, there are customers already use our solution. For example, some of you already know about BioStar API. And in fact, some of these requirements were already met by BioStar API. Because BioStar API is just REST API, you can use almost any language you want. And since it is web-based API, it is kind of cloud-ready. Then what is the difference between GSK and BioStar API? The most important thing is that BioStar API needs BioStar to server. And BioStar to server is not so lightweight. So if what you want is just some basic functions of API, maybe BioStar API is too heavy. So we thought that GSK could be a more proper alternative in that kind of scenarios. And as I said earlier, the current customer device SDK, if they have some issues, for example, some scalability, then in the case two, we think that GSK could be another alternative. And we also targeted some new customers. Since it provides many other programming languages, we hope that GSK could attract new developers to use our product. So this slide shows some technical details. So I'm not sure if some of you are from marketing field. It might be boring, but anyway, for some of you must be engineers. So I'll give you some more technical details. To meet the design goals, we made two important technical decisions. First, we choose Go language as our implementation language. In fact, it was first time in Suprema we developed something with Go language. There were several reasons we choose Go for the new SDK. In fact, the most difficult part of the current device SDK was to handle lots of devices. To handle hundreds of devices, it is based on thread pool model. But thread pool model can be problematic, especially when devices exceeds hundreds, the number of devices exceeds 100. But in case of Go, Go was developed by Google, especially for that kind of scenarios. So it can handle thousands of concurrent tasks with very little system resources. So we thought that Go might be the best fit for our goals. And another attractive point of Go language is that it is very easy to deploy. Since the SDK is not in itself a product, it has to be used with your application. So its deployment should be very easy and simple. And in case of Go, it just statically link all the libraries it depends. So the end result is just one binary. So installing GSK is very simple. Just copy the binary into your working folder. That's all. So that is why we choose Go language as our programming language. And after that, as I said, one of the main goals is to provide support for many languages. So we choose gRPC for the purpose. gRPC was used at first internally in Google. There are hundreds of small teams in Google, and most of them use different languages for their purposes. So there must be some common ground, some common communication framework to intercommunicate between these small teams. So gRPC is based on protobuffer, and protobuffer is a kind of messaging exchange platform which can provide many programming languages. So we choose gRPC as our middleware. So I thought that with these two technical solutions, we could develop GSK rather easily. So this table summarizes the differences between device SDK and GSK. And I think most of these are already covered by the previous webinar. So yeah, device SDK is provided as a library, and it supports Windows and expiring Linux and C++ C#. In case of GSK, it consists of two parts. Yes, it's device gateway and also master gateway. And it also provides client libraries for several programming languages. And the gateway can run on Windows, X86 and ARM Linux and macOS. And as of version 1.1, it is same with version 1.2, 6 languages are supported. And one device gateway can handle up to 1,000 devices. And since one master gateway can handle 100 device gateways, one master gateway can handle 100,000 devices. Yeah, so the previous table shows very rough comparison between two. I will show you some very concrete example to show you what are the main differences between device SK and GSK. Let's assume that you are developing a very simple time and attendance application with job codes. There are only three basic parts to write your application. First, you have to connect to devices. With device SDK, there are several APIs, but I think maybe the most simplest one is connect device via IP function. And if you have to connect 10 devices, you have to call 10 times this function. But in case of GSK, there are one function, add async connection, and you only have to call this function once. And even after this function call, if some of the device is disconnected, the device gateway will automatically reconnect them in the background. So I think the device management would be very simple, much simpler with GSK. And after that, you have to enroll users for time and attendance application. And you have to enroll users. And with device SDK, you have to use two APIs. First, you have to enroll users with VS2 enroll user function. And after that, if we want to set new job codes for users, in fact, you have to use the same API because device SDK does not provide any partial update. So you have to call first VS get user infos. And after that, you have to change the part of the users and again call VS inner user. It could be quite cumbersome if there are many users and many devices. But with GSK, first of all, there are some function with multi in GSK. These functions can do same work to multiple devices at the same time. So if we want to enroll same users to 100 devices, you only have to call this function once. And another advantage of GSK is that it has some partial API function. So to change job code only, you don't have to call get user. Just set job code will handle all the complex work at the row level. In addition to job code, you can change cards, face, fingerprints without getting the user information. And after that, the goal of time and attendance application is to get the event log with time and attendance key. So in case of device SDK, there is a single API for all kinds of application scenarios. So as a result, the data structure is rather complex. But in case of GSK, there are several types of event log types for each application scenario. So in this case, you can call tna.getJobCodeLog, and it locally filtered log record and returned only the events with job codes. So it's a very simple example, but these kind of scenarios are we are thinking when we design the GSK. So yeah, it's the structure of event flow, but I think it is too technical, so I skip this slide. So another important difference between device SDK and GSDK is that GSDK is an independent application, not a library. So it can be deployed in several different ways. Firstly, you can just use the device as gateway, same as the library. If you run the device gateway at the same machine with your application, in fact, the difference is minimal. But since the device gateway is itself a separate application, you can install it to another machine. Especially, you can install it on cloud itself. So this kind of architecture is possible. You can install device gateway on cloud, and your device will connect to the device gateway, and your application will connect to the device gateway on the cloud. In fact, already some of our customers are developing our application in this model. So this slide shows that you can very easily develop cloud-based application. But in fact, this architecture has some problem. First, even though device gateway can handle up to 1,000 devices, in some cases, it is not enough. You might have to handle tens of thousands of devices. So in that case, gateway cannot handle that. And another problem is that some of our customers might not want to install their device gateway on cloud itself for security reasons. And another thing is that many cloud-based applications should provide multi-tenant support. But in this architecture, multi-tenant is not so easy to provide. So that is why master gateway was introduced in our previous version 1.1. In fact, the version 1.1 is mainly focused on the master gateway. Master gateway can handle multiple device gateway. So in this case, you can just install master gateway on cloud and install device gateways on production site. And as you can see, multi-tenant is very easy to implement in this architecture. Since you can divide device gateway into tenant, and each tenant can only access to their own device gateways. So we think that master gateway is a very good solution for implementing, simple cloud-based application using BioStar devices. So master gateway was incorporated in version 1.1. So now our main part of webinar, the new features of version 1.2. There are several new features. And first of all, we provide zones and lift features in version 1.2. I'm not sure how many our users are using these features, but anyway, some access control application needs some advanced feature such as anti-passback and lift control. And these features were missing since until version 1.1. And version 1.2, we provide 6 zones and lift API. But there's one limitation in our zone support in GSK. The GSK only provides local zones. As you already know, there are 2 types of zones. Local zones means that all the devices of a zone should be connected by a RS-485 network. On the other hand, with global zones, you can configure a zone with Ethernet connection. But you need BioStar 2 server to provide global zones. So GSK only provide local zones. Other than that, its functionality is same what you can do with BioStar. And V1.1 is our extension output extension module, and it has 16 arrays, and you can use this terminal to control lifts, and lift API is provided. The previous zones and lifts are missing features compared to device SDK, but FaceStation F2 is new model. As you know, it was released a couple of months ago. So this new devices is also provided by version 1.2. The main characteristic, the major differentiation point of F2 is that it provides both visual and IR cameras. So by combining these two technologies, it provides very good authentication performance. But unfortunately, in view of the developers, the template formats are not compatible with the old ones used by FaceStation 2 and FaceLight. So as you can see, I have to add some new data fields for our data structure. But you can still use the same API. The scan API can be used, and the internal differences are handled by the device gateway itself. Another difference is that some F2 model also provides fingerprint sensors. And since it provides multimodal functions, there should be some additional authentication modes. For example, this face fingerprint, it means that users have to authenticate fingerprint after their face. These are not, in fact, these modes does not make sense with the previous model because they only either fingerprint or face. But in case of F2, since both modes are possible, there are some new combinations. So we provide some new authentication mode only for FaceStation F2. And these are not very complex, but anyway, to provide you some example application will be provided for you to learn how to use this new FaceStation F2 with GSK. Another new hardware recently introduced is thermal camera. As you know, COVID-19 is very significant issue, and so you can use thermal camera with some of our models, FaceStation 2 and FaceStation F2. So with this thermal camera, you can check the temperature of users, and in some cases, you can disallow access some users with higher temperature, etc. And in case of FaceStation F2, it also provides new function which can check if user is wearing a mask or not. It is only provided on F2 now, but anyway, so to provide these thermal cameras, new thermal APIs are provided in version 1.2. And also, I also wrote some simple examples to show you how to use these thermal APIs. And there was some new features for master gateway too. There are 3 types of connection APIs in GSK. First one is synchronous API. It is simplest one, just directly connect to the device. And this synchronous call should be used one at a time for every device. And GSK, as I said earlier in the job code example, we provide asynchronous APIs, and it can handle device connection automatically at the background. But the problem is even though we can handle device reconnection, it cannot handle gateway reconnection. It means that if the gateway is reset for whatever reason, you have to set asynchronous configuration information again. In fact, it is the limitation of device gateway itself, because the device gateway does not have any database. So you have to reconfigure connection every time the device gateway restarts. But however, master gateway has its own database. It is a very simple one, but anyway, it has database. So we add some new functions to store the connection information on database. So if you use master gateway, you don't have to reconfigure the connection information again, even though some device gateways are reconnected. So that is the major change in master gateway in version 1.2. Yeah, so lastly, I added some new examples for the client SDK. In fact, 3 examples are added. First one is user example. In fact, some of user APIs are handled in our previous example, fixed start guide, but it was too simple. So I extended the example to show you how to enroll credential, and how to change authentication mode, and how to read log records with filters. So that is a new example. And since thermal camera and F2 are added to version 1.2, I provide thermal API example. It is very simple, but I hope that it will shorten your running time to learn how to use the new APIs. And I also another simple time and attendance example for simple time and attendance application. So this code is from Java example for user. In fact, we provide this new example for all 6 languages. Yeah, so I think that concludes the new features of version 1.2. And now I briefly talk about the new features we are considering in our next versions. So as of version 1.2, in fact, there are 6 examples, but some of our clients already asked more examples because gRPC has its many advantages, but it has some shortcomings too. Since in use ideal proto buffer, in fact, the data structure is different for each programming language. So API itself may not be enough for developers to write their own application. So many more examples will be very helpful. So from version 1.3, we will try to add more examples, hopefully covering all the major APIs of GSK. And another thing is that in some cases, you might have some problems in debugging the gRPC part. In fact, gRPC is kind of a black box to GSK. So if there is some connection issue with gRPC, it could be very hard to debug. So we will add some additional information to how to troubleshoot these kind of cases in later version. Or even before version 1.3, we will give you some troubleshooting guides about common troubleshooting cases. Another example we are considering now is the example of master gateway. As I described, master gateway is a very powerful feature, but it might not be so easy for develop your application, especially for the first time. So we are planning to write an example application, which will show you how to manage multiple gateways and multiple devices in cloud environment. And with that, we will also planning to provide some mobile clients in iOS and Android. In fact, this mobile cloud example is not yet fixed, but hopefully in next version, we will provide an example of mass gateway. So yeah, it's almost end of my presentation. I believe that maybe one of the most important things for every SDK is developer support. Even if any SDK has how many powerful features, if the support is not adequate, it could not succeed. We know that. So another thing we are considering now is that how to support you better technical support. Currently, we have some support channels. The main one is our technical support side handled by our technical support team. And another one is, I'm not sure many of you know this, but we already have technical forum for SDK inquiries, but this is not so well known and it has some technical issues, so it is not so, its usage is not so great. So we are also considering some new ways to provide more direct and more quick technical support. So one of the candidates is just to use the GitHub site. Currently, we are only use the GitHub site just releasing our software, but we might be also able to use the issue function provided by GitHub. It is very basic, but I think it could be enough for provide technical support. But it is not yet fixed. So for now, you should use the current technical channel. But anyway, even with the current channel, if you ask any inquiries, I or other engineer will try to answer question directly. So if there are some confusion in the early phase of GSK, if you have any question, just let our technical support team know, and we'll do our best to provide you the technical support as best as we can. Okay. So that's the end of my presentation. So we will have short Q&A session. So in fact, there are several questions already, and Kate also already answered most of them. So last question is from Stefan. Stefan asked, what strategy would you use to test the loading capability of the new GSK? Yeah, as I said, handling thousands of devices is the most difficult part of the SDK design. So as I said, we use Go language and some other technical platform. And to test this scalability, we use mock devices. So mock devices is a kind of software. It emulates our devices. So in our testing phase, we generate thousands of mock devices and we test our device gateway with mock devices. So I believe that we already test at least 1,000 devices with a new SDK. But currently, we have some issues with the mock devices. So I did not include in my slides, but we are also considering enhance our mock devices for more difficult or more heavy scenario. So yeah, that is also our to-do list for future versions. So yeah, another question from Ramji. Device gateway can be run as service on the Windows. Of course you can, but you have to do some additional work. Yeah, we don't provide any script or things automate this process. So it's just simple, plain Windows binary. So you have to do some additional work to run this as a service. I hope that. Okay. Juan asked that new SDK is required to update most of device models firmware. I think not. Of course, new models, for example, F2 need new firmware, but other than that, I think you don't have to upgrade firmware for general cases. So in fact, most new features are missing features compared to device SDK. So in fact, it is not new in terms of firmware. So I think that in most cases, you can use your existing firmware. I think I answered the same question of Chris. Does it work with old firmware? Yes. And another question from Christian. GSK work for .NET Framework and .NET Core? Yes. We provide C# and you can use .NET with GSK. And even if device SDK can be used with .NET Framework, I think it would be much easier with GSK because it is not a wrapper library, it is native C# library. So yeah, you can definitely use GSK with .NET. Okay, any other questions? Yeah, thank you very much for your time and interest with our GSK. And I hope that this webinar would be the first step to provide you better developer support in the future. So if some issues that are not covered by this webinar, if you have any question, just please let me know. Then, as I said, me and our team will do our best to provide you the quick technical support. Thank you very much.